Hi, in this video we're going to create this sketch which we looked at in the class packet. So a couple of things, because we haven't really had a chance to discuss too much about drawings themselves. This type of notation here, the 4x, implies that there's going to be four parts of the geometry of the sketch that are going to be identical to each other. So 4x, this symbol here refers to the diameter of a circle and 0.80. So this reads this as there is going to be four items that have a diameter of 0.80 inches. The arrow points to this one. So we look on the drawing and find out that there are four of these. The implication again is that these are going to be holes in whatever this larger part is. We also have another one of those callouts down here. Again, we're expecting to find 4. R, capital R stands for the radius, and the radius is 0.80 inches. So that implies that this curve here has a radius of 0.8. This one over here will have a radius of 0.8. And then by implication, these outer curves here and these outer curves here both have a radius of 0.8. The last type of call out here is 2x, radius 0.40 inches. So we see one here, and by implication, this one is over here. And you'll note also that the arrows have slightly different ways of looking at things. This arrow here is just pointing towards this circle, whereas this one here, the arrow comes from a center point and comes out. So it is telling you where the center of this arc or radius is going to be. Over here, there is again no center point located, so there's an implication here that this curved line is going to be tangent to this curve, and it's going to be ends up being tangent to this straight line. So there's a lot of implied information in here, and you'll hear that term, or I'll use it in classes, implied dimensions. So we have a line here that connects through these two holes. This X here with these extended lines out is referred to as a center mark. So it gives the center of this circle and by implication the center of this arc. This dotted line here is referred to as a center line, or in this case it's being used as a construction line, which implies that this circle and this circle are on the same horizontal line. And this dimension here is telling you that these two circles and this horizontal line is 2.3 inches separated from this circle. And by implication here, this center mark here and this center mark here are taken as being on the same level, as well as this line here. It's not explicitly indicated, but you are supposed to understand that, again, as an implied dimension, as if you were a machinist. The horizontal distance between these two circles is 6. The horizontal distance between these two circles is 4.8. And while it could be implied that this is a symmetric object, they are explicitly calling out a distance between this circle and the horizontal offset as being 0.6 inches. Of course, 0.6 plus 0.48 plus 0.6 equals 6 inches. Now what I've done here, I've gone over the original drawing that was taken out of an old drafting textbook. Now what I've done here on the next slide is a drawing that I've created using SOLIDWORKS from a part that I've created. I haven't done much in terms of varying previous drawing. The only things I did add in are really two construction lines here to implicitly state that the center of this circle is in line with this horizontal portion of the part and connects over to this one. Other than that, I haven't made any changes. Now, what I've done in the next slide is I have explicitly called out the symmetry of this part by installing or putting in an actual center line that goes through the center of the part. And what's implied by a center line of this type is left to right symmetry. So in this case, the call out for the distance from the center line to this upper circle is 2.4 inches, and the call out from the distance of the center line to this circle and this radius, of course, is 3 inches. Other than that, I've left the implied or the other than that, other than that, I've left the callouts for the internal circles and the callouts for the 4 radiuses on the outside the same. Which one of these 3 drawings is correct? There is no answer to that. Any one of these would be acceptable to give to a machinist to go ahead and make this part. So what I'm going to do in the next video is I will go ahead and create the actual part.